You're welcome back to our tutorial on primer designing. Uh, from our previous video, this is where we ended. If you've not watched the previous video, I will encourage you to go check it up and make sure you found out how we arrived here before you go on in this particular video. Okay, this is the result of the primer designing. This saver has uh, picked our primer, and as you can see, we always have two primer. As we highlighted, we have the left primer and we have what, the right primer. Okay, the left primer runs from 3 to 5, whereas the right primer runs from what, 5 to what, 3 direction. Okay, this portion here is what the primer that have been picked from the left. Okay, whereas if you scroll down, this one on yellow here is the primer that be what, picked from what, the right. Is these two portions correspond to this. This is the right, which is the down one, whereas this is the top, which is this particular one. Okay, so this is what we have as our two sequence. In sequence, okay, while picking base pair sequence, you must ensure that the primer, from what you can see here, it has sorted out our different primers. Remember, also note very well that while picking primer, the server will at least pick up to 4 to 5 what, different primers for you. For instance, this is number 5, pay 5, this is pay 4, this is pay 3, this is pay 2, and then this is pay 1. Okay, it has picked 5 different primers, okay, which can be used for our sequence, okay, for the PCR of our sequence. So what this first one simply means, I sorted out this first one based on certain properties which we are going to explain here now. So these properties have been considered before making this the best pay out of these particular 5. The number one factor that was considered here is the length of the base pairs, which is this particular group here. Okay, each of this particular group here, that's the base pairs. According to primer designing criteria, you are not meant to pick a primer that has base pair less than 18. Okay, less than 18 and greater than 27. Some may say 30. Okay, so but while picking, make sure your primer base pair or length, base length, is between this particular region, 18 and 30 or 27, as may be the case. So this is what we have. From this, our base pair is 20 base pairs. If you count this 1 2 3 4, you get 20 of this here. Okay, then after that, it gives us the melting temperature, which is this, is fine. Then another very important portion again is the GC value. Okay, the GC to AT value. Okay, we have GC to what, the AT value or percentage. This particular GC is telling you the guanine cytosine base pair. We learned that GC has triple bond, okay, in their base pair, whereas AT has what, has just 2 bonds. The higher the GC bond in the primer design, the better, because this helps to give a more stable primer while designing. Okay, the higher the triple bond, the stronger or the more stable the design, the primer, whereas the higher the what, the other AT bond, which is double bond, the what, the lesser the stability. So here we have, at least you must have at least 50% GC value to have a stable primer. From what we have here, our GC value is what, is 50%, which is fine. Okay, the same thing happens here in the second primer, the primer to the right. The GC is 50 also percent, is fine by us. Okay, so these two major factors were, and few other was what was actually considered and made this one the first base pair, or the first pair of our primer here. Let's check the rest of the this thing. Okay, here we also have, here we have okay, this is very similar. We have our base length here to be 20, our base length here also to be what, to be 20, and all that. Okay, this is very similar. Okay, and Then here we have also another one. This is page 3. Okay, the length is 20, the length is 20, is fine. This one, you can see where they start and the rest ended. This start means where the pay started, okay? And this for the left one, this for the right one. Okay, okay, these are the melting temperature. This has higher melting temperature, okay? Which is also being considered. The lesser the melting temperature, the better. Okay, we also have the GC value here. This is 55, whereas here is 50, okay? But we have ourselves here, this is 0 and this is 2. And then this melting temperature must have been one of the reasons why this was not chosen as the what, as the best. And the rest, you can also have, see this place also have greater melting temperature and the rest. So this and a few other things is what we consider. From here you can see this, I think, has the lowest melting temperature when compared to the rest of the this thing here. Sure, that's another point there. The melting temperature, this is 59.7 and 60.2, whereas the one they choose at the highest has what, 59.7 and 60.0. Okay, so you consider the base length, you consider the melting temperature, you consider the GC to AT ratio, you also consider, okay, and sometimes self also, my SELF also matter. Okay, so this is how we were able to pick our primer. So if you're now performing your PCR, this is the primer you make use of, and then this for the left and this for the right. Okay, primer you have got from this particular what, this particular gene or this particular FASTA sequence you identify from your organism, or the DNA sequence of what you are working with. So with this, you have done what, you have picked your primer, and you can simply inform those in the lab using the PCR to make use of this while doing the PCR of this your gene or this your particular FASTA sequence. So this is how we pick our primer, and make sure you consider these factors, okay, because you will surely report them while making your write-up on your primer designing and all that. Thank you, and see you in our further tutorials.